Next example is the common source, but the bias circuit is the drain feedback. This is drain feedback bias circuit. Okay, so this is the given parameters. So K is not directly given, but ID on and VGS on is given. So from this information, we can get the value of the K. So K will equal to ID on over VGS on minus this is the equation for the K. So K is ID on is 6 milli, and then VGS on is 8 minus threshold is 3 square. This is equal to 0.24. Okay. So this is the K value. And then IDQ is given as 2.7 milliampere. Okay. As usual, first we need to draw the mid-band equivalent circuit. So we start from the input source. This is symbol as the ES, and then we have there is the signal resistor 600. Okay, 600 ohm. Okay, so the 1 microfarad is short circuit. So after this, this here we have the two ways or two junctions. So let's consider the gate towards the gate first. So at the gate, okay, and the gate and the source, we have this open circuit, and then the source is directly connected to the ground. Okay, between source and drain, we have the current source, which is GM VGS. The small RD is infinity. We assume the small RD is infinity, so it will not appear. Okay, at this point, at this node, we have three connection. The first connection is the 2K here. This is 2K, and then the second connection is the 2K as the RL, and then the last connection is the 10 mega ohm. Okay, so this is the AC equivalent circuit. Okay, for this for the current source, the GM can be calculated using the 2 square root K IDQ. So the K is 0.24 milli and IDQ is 2.7 milli. Okay. This will give you the transconductance of 1.61 millisiemens. This is the solution for AC equivalent circuit. Okay, the next analysis is the calculation of the input impedance. So what is input impedance? Input impedance is the impedance seen from the input port. This is the ZI. Okay, at the ZI is equal to VI over II. So VI is voltage cross here. So this is VI, Okay, what is II? II is the current towards the input. Okay, so we know that the VI is equal to VGS. So you know VI is equal to VGS. How about the II? So II can be defined by uh, writing the KCL equation at this point. Okay, so this is KCL here. So from the KCL, so you know that the II is equal to, okay, if you do the KCL, the II is entering this node, so II is positive. Okay, so next is we see the GM VGS here is exiting, so you see here this is negative GM VGS, and then we also have this current here exiting. So this current here, we can use the Ohm's law. The voltage across the 2K is denoted as a V out. So this is the V out. So the current will be V out over the combination of these 2K in parallel. So this is minus V out over 2K parallel with 2K. This is equal to 0. Okay. So here you know that you see that VGS can be replaced by the VI, and then we see the V out. So in order for us to analyze the input impedance, we need to have the equation that only has the VI and II. So here VGS is replaced with VI, so it is okay. How about the V out? So how are we going to redefine the V out? So V out can be defined by the Ohm's law, the definition of the current at the 10 mega ohm. So the current at the 10 mega ohm is II. So here the II is equal to the voltage across the II is VI minus V out. Okay, since this point is the VI, this point is V out. So VI minus V out over 10 mega. So this will give you V out is equal to VI minus II 10 mega. Okay. From the first equation and the second equation, you can rewrite the KCL as it will become the II minus GM VI, because VGS is equal to VI, and then minus V out is equal to VI minus II 10 mega. So this is VI minus II 10 mega. This is over 2K parallel with 2K is 1K equal to 0. Okay, you solve this equation, so you will get the ZI equal to VI over II. This will give you the value of 10 mega over 2.61. So this is equal to 3.83 mega ohm. So this is the input impedance. Okay. So again, how I get the ZI? Because if we start from this equation we have II and VI. So the GM here can be replaced with the value of 1.61 milli. 1.61 milli. So in the equation we only will have the variable of II and VI only. Okay. Okay. So next is the output impedance. So the output impedance. Okay, let me redraw the circuit again. The circuit is this is another way to draw the circuit. It's 10 mega ohm and this is 600. And we have here, this is the RD 2K and then RL 2K. Okay, the output impedance is the one that we see from this 2K. Okay, when we calculate the output impedance, the Z out is equal to V out over I out in the condition of the VI is equal to VI slash the VS equal to 0. So here this is the VS here. You need to ground it because we assume that let me correct this one. VI or VS is equal to 0. So when VS is equal to 0, it's grounded. So this point is grounded. So the analyzed circuit will be something like this. This is the 2K. This is the Z out. This is plus V out. And this is the I out current. This is 10 mega ohm. This is 600 mega ohm. Okay. When you see this type of circuit, there's a high possibility that VGS is equal to 0. So how are we going to verify the VS is equal to 0? So by what we can do is we can define the VGS. So here VGS is the voltage across the 600 ohm. And then we know that the voltage here is equal to V out because this is V out and this is V out. So the VGS is voltage division between the 600 and 10 mega ohm. So VGS is equal to 600 over 600 plus 10 mega times V out. Okay. From this analysis, you see the 600 over 600 plus 10 mega, this is almost equal to 0 because 600 over 600 is, if you compare 600 with 10 mega, is the difference is many orders of different, so it is equal to 0. So when VGS is equal to 0, GM VGS is also almost equal to 0 ampere. So this is open circuit. Okay. So what will happen is this is grounded. So at this point it's grounded, so we can ignore the 600. So we can remove the GM-VGS. So what you will see is only the Z out is equal to, you will see only 2K and 10 mega ohm. Okay. So this parallel equation will give you the approximately the value of 2 kilo ohm. So the solution for the output impedance is quite simple, 2 kilo ohm, but actually the analysis behind the solution is not that simple as you may expect. Okay, this is the output impedance. So next we go to the voltage gain. So what is the voltage gain? Voltage gain is, let's say we calculate the V out over V in. So again, we redraw the circuit. So this is the Vs, and then we have this signal resistor, internal resistance, 600 ohm, and then we have here the VGS, have a 10 mega. This is GM VGS, 2K, and then this is 2K. Okay, the output voltage is around the 2K, and then let's calculate the AV equal to V out over VI first. So the VI is voltage at the input. In order to calculate this one, we use the same approach with what we have done for the input impedance. So we start with the KCL. So KCL at this node. So KCL as this node. So from the KCL, you see here, this is the current entering this node is II, and then we have the current exiting this node is minus GM VGS, and then we have another current is V out over 2K parallel with 2K. This is equal to 0. This is the KCL. Okay. Here we define the VGS is equal to VI. And then another is, you know that II is equal to VI minus V out over 10 mega. So from these two equations, the KCL can be rewritten as VI minus V out over 10 mega minus GM VI minus V out over 2K parallel with 2K is 1K to 0. So we insert the GM value, VVI, V out 10 mega. The GM value is 1.61 milli. So this is VI, 1K equal to 0. So from this equation, we can have the relationship of the II it's not II. So we have the equation of we'll get something like this: 10 power of 4 V out is equal to minus 2.61 Okay, Okay, let me recheck this solution. Okay, let's do this solution. Okay, so 10 mega is equal to 10 power of 7. So we need to times all of this is 10 power of 7. So you get here the VI minus V out minus 1.61. So milli is 10 power of minus 3. So times 10 power of 7 is 10 power of 4. Okay. And then this one is also will become the 10 power of 4. Okay. So for this one, so this is the VI is 1. 1 minus 1.6 1 times 10 power of 4. So this is almost equal to this 1.61 10 power of 4. So this is 1.61 times 10 power of 4 VI, and then this V out is also will become, okay, so V out over the V in will give you minus 1.61. So this is the solution for the AV. Okay. If you know the AV, you can calculate the AVS. So AVS is V out over VS. So this is equal to V out over the VI times VI over VS. So V out over VI is minus 1.61, and VI over VS is the Z in over Z in plus 600. So this is minus 1.61 times the Z in is equal to 3.83 mega. Okay, the input impedance is quite high, and this is 3.83 mega plus 600. So this one is, there will be not much different. So this is roughly equal to the same 1.61.